Hey guys, today is going to be about multiplying and factoring polynomials. We're going to start with multiplying a monomial by a trinomial. Now, it sounds kind of crazy, but it's not going to be too bad, so don't panic on me. Okay, alright, so all you're going to do is use the distributive property. So what is on the outside, you're going to distribute to each factor. Okay, alright, or each term. So how do I do that? Okay, I've already written you some steps. You're going to distribute. Number 2, we're going to multiply the coefficients, and then we're going to add the exponents. Okay, so here, let's just do the first one together. Okay, remember, if there's nothing there, it's like a 1. So negative 1 times 9, we get negative 9. Now, what do I do when I multiply exponents? Remember, we add them. So it's x to the 3 plus 4, which is 7. Okay, that is only the first one. Okay, so that one's done. Alright, so let's go to the next one. We're going to distribute it to the next one. Negative 1 times negative 2 gives me positive 2. Alright, what do I do with my exponents when I multiply them? I add them. 3 plus 3 gives me x to the 6th. Okay, and then I get negative 1 x cubed times 7. Notice it's negative 1 times 7 gives me negative 7. Now what do I do with this? Okay, well, you have no x here. Think about it as being like x to the 0. So x to the 0 plus 3 is x cubed. Okay, so now you have multiplied a monomial times a trinomial. All you have to do is distribute it to each term. Okay, remember, you multiply coefficients and then you add exponents for each term. Okay, so this would be my answer. Okay, I have one down here for you to try. You're going to do 6n, which is the monomial, times the trinomial, which tri means has 3 terms, 3n cubed minus n squared plus 2. So go ahead and work that one in your journal. And make sure you simplify last, which means combine anything that could be combined. Okay, we have nothing to simplify here. Okay, alright, so I'll let you try this one on your own. When you get done, your answer should be 18n to the 4th minus 6n cubed plus 12n. Okay, alright, so that is multiplying one monomial times a trinomial. You could have more or not. Okay, alright, so make sure you're taking notes on this. You have to find the greatest common factor. Okay, so we're looking at this polynomial, which happens to be a trinomial. We want to know how can we factor that out. So we want to know the greatest common factor in each term. So the greatest one that can be used in each term. So how do I do that? Well, you're going to list the prime factors, which means factor it all the way down for each term. I've already separated the terms, so this should have another L there. Okay, all right, so how do I multiply this down? Okay, well, 5 times x times x times x, okay, should give me 5x cubed. Okay, what is my prime factorization for 25? Well, you go down as far as you can, which would be 5 times 5, and we have 2 x's. Okay, what about the prime factorization for 45? Okay, we go down to, we got 9 times 5, but that can go further to 3 times 3 to make sure all of my numbers are prime. 3 times 3 times 5, and then we only have 1x. Okay, alright, so we want to identify the factors common to all of the terms. Okay, so I'm going to switch colors for us. What do they have in common? Well, they have a 5, and they have an x. Okay, alright, so what is my greatest common factor for this? Is equals 5x. So all that is what do they have in common? Remember, when we do a prime factorization, you go down to the prime numbers that you multiply together to give you your number. Okay, so you have another one. So the factors they have in common is the greatest common factor. If they happen to come down to have like 5 times 5 times x, your greatest common factor would be written as 25x. You would go ahead and multiply those, and you could factor that out. Okay? All right, so we will use this to help factor monomials and polynomials, which will be on the next slide. So here's you another example to try. Okay? Remember, you're going to separate each term, factor it out, and then figure out what they have in common. That will give you your greatest common factor. Okay? All right, try that one on your own. You should come out to 2 times 2 times x. So your greatest common factor equals 4x for that one. All right. So now that we've factored it out, we're going to go further. Okay. We're going to factor out a monomial, which means that I want to take out the greatest common factor from the whole polynomial. So in this example, I want it to look like we started. I want some number times something, okay? But you can see from our example, we are not starting that way, so it's like working backwards. We want to factor out something, okay? All right, so how do I do that? It's not hard. Do not panic on me, okay? So I've written you some steps already. First thing, we're going to factor out each term, just like we did just before, okay? So what do I do? All right, 2 times 2 is my factorization for 4. Then we have x, 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 x. Okay, 24. We can go down to 6 times 4, which is 2 times 3. And then 2 times 2. Okay, so you got 2 times 2 times 2 times 3. And then we have 3 x's, x, x, x. All right, what about 8? So that we know that's 2 times 2 times 2, and then just 1 x. So if we change colors, what do they have in common? Okay, they have 1, 2. They have 2 2's. And we have 1 x. Okay. So what is my greatest common factor? 2 times 2 times x. So 2 times 2 times x, which gives me 4x is my greatest common factor. Okay, so now my greatest common factor, we're going to pull that to the outside. Okay, so we want to pull that to the outside. We're going to put what is left on the inside. Okay, so now let's change colors again. So what's left on the first one? 1x, 2x, 3x, 4x. So that's x to the 4th. Okay, what's left here? 2 times 3, which will give me, and notice we have subtraction here, so keep it that way. Okay, 6. And how many x's? 2, so that's x squared. Okay, what's left here? All we're left with is 2. Okay, so you can see if I were to factor it back out, I would, you could check yourself. So what's left up here goes on the inside, and you can check yourself because you can just distribute and see. You should, when you distribute, go back to this equation. Okay, all right, so I'll give you another one to try here. Okay, I'm going to let you try that one on your own. Just from looking, I would say you should be able to pull a 4x squared out. You would do with x to the 4th plus 2 x squared plus 3. Okay, that should be your answer when you work that out. All right, so that is how you factor out a monomial. All right, so of course they want a real life application. So how do we do it? Okay, we're going to factor a polynomial model. Okay, so our scenario is a helicopter landing pad is sometimes marked with a circle inside a square so that it is visible from the air. What is the area of the shaded, I have lots of typos, sorry, region, region region on the landing pad shown. Answer in factored form, please. Okay, that means we want to factor it out. Okay, so how we do this is we want to find the area of the square. Okay, so we see that one side is 2x. I've already given you the formula because I'm nice. Okay, so what do? Okay, we put in 2x squared. Okay, so square 2. 2 squared is 4. X squared is 4x squared is my area of the square. Okay, what is my area of the circle? Okay, well, my radius, the formula is pi r squared, so my radius is x, so just fill it in, pi x squared. Okay, so we're going to see if they have anything in common. So we have pi x squared and we have 4x squared. Okay, so if I pull this out, I would be left with pi times x, and then I would be left with 2 times 2, it's not writing, times x. So what do they have in common? Okay, they have 2 x's in common. Okay, so the GCF should be x squared. Okay, so we can factor that out to be x squared, and we want to do the square minus the circle. So think about square minus the circle. So we would do, your formula would be 4x squared minus pi x squared. Okay, so we want to know so we have x squared. We take that out, we're left with 4, and we're left with pi, so minus pi. Okay, all right. Sorry I didn't shade that like I should have, but the shaded region would be this section. We want to know what is the area of that section, which we figured out. Okay, all right, so work your own with the length of the side. So if we had our landing pad here with the length being 6x and then the radius of my circle being 2x, what is the formula for that shaded region around it? Okay, all right, so have fun with that one, and I will see you tomorrow. Hope this helps. Have a good night.